Okay, last year, same day, I think we took a quiz also. The same thing. You see, you observe a pattern. The see the overall pattern, right? How things happen. Slowly, you observe that the same thing is happening, same amount. This is the natural law. I mean, this is nothing, no magic here. By the way, anyway, uh, so let me try to tell you a few things about this elliptic curve. We started with elliptic curve, and especially for reals or complex. And I told you how to add 2 points on the elliptic curve. And there were 3 cases, if you remember, from the last lecture. And this quantity is very, very important in this equation, x cube plus ax plus b, right? So I will give you examples also how to compute these points, okay? But first of all, let me complete the addition what we were doing. See, so we take 2 points P and Q, right? And then draw a line. It will intersect some other point on the curve. Call it R prime, and take the reflection of R point with respect to x-axis, and that is your point R. So P plus Q will be R. Okay, and so we can do certain calculations here. As I mentioned, there are 3 cases. Case 1, how do you define addition? Okay, which I told you, and you can compute this value of lambda and so on in case 1. Okay, so we computed this lambda here. So y3. So basically, if we take 2 points x1, y1 and x2, y2, their sum is x3, y3, where x3 is this quantity, y3 is this quantity, and lambda is this quantity. Okay, so we can find a. Obviously, you can implement it and you can do the thing. So the question is, this is one case. Case 2, uh, you know, when y1 is when y2 is minus y1 or something like that, then what happens in case 3? So there are 3 cases. So you will see that in case 2 also. So let me do that case for you. First, case 2. So when x1 is equal to x2 and y1 is equal to minus y2, in that case addition is something like this. I mean, so x1 is equal to x2, I am calling it x, and if I call it one of them as y, so the other one will be minus y, right? This will be point at infinity for every x comma y on this elliptic curve E. So this and these points are inverses of each other. And case 3 here, if P is a point x1, y1, and we want to add P to itself. Okay. So here we can assume that y1 is not equal to 0, because if y1 is equal to 0, we will have case 2. Okay. So without loss of generality, we can assume y1 is not equal to 0. Now this case is similar to case 1, except that I am line L is tangent to elliptic curve at the point P. Okay, so this is something is important. So basically, we differentiate the equation of elliptic curve. We will get 2y dy by dx because it's a tangent thing. So when we differentiate our elliptic curve, this curve I am going to differentiate to find the tangent. So this will be this quantity. So slope of the tangent will be lambda is equal to 3x1 square plus a divided by 2 times y1. So everything else is similar. The only thing is that the value of lambda this time we can compute like this in the third case. Why these things are happening and so on, the intuition is basically, you can try to find out. So basically, if I have to do a research and try to find out how do we find this relationship, so basically you can actually, try to observe a pattern, look at all the points and see, what is happening, and then, you conclude. So basically, now we know that geometrically how, we can approach to this problem. Anyway, so now let me take one example. But before giving example, I would like to define. So till now I talked about elliptic curve. So y square is equal to x cube plus ax plus b when the coefficients are real or complex, right? So that is a one domain when we are looking at infinite field. What happens if you go to integer modulo p? Something will happen when p is a prime because that is another modular field. I can talk about it. So let me define precisely what happens over modular field. How do we define uh, elliptic curve over modular field? So in this case, we would like to work on ZP. Okay. So P is a prime not equal to 2. Two cases a little bit different, so I am just avoiding that. So elliptic curve y square is equal to x cube plus ax plus b, and the coefficients a and b are over ZP. And we are also looking for these solutions actually. So pair x comma y in ZP square, right? ZP cross ZP, which is a solution here, right? So basically we say that this is modulo P. So now A and B are in ZP with certain conditions. 4a cube plus 27b square is not equal to 0 mod P. Remember, this is the discriminant, and this should be not equal to 0. And we have also a point at infinity. So essentially the curve is defined like this, modulo P, A and B are in ZP, and this discriminant is not equal to 0. Later on, actually, when we took all this structure over integer modulo n, so the discriminant should not be a. So basically, discriminant should not be 0 means it should not be a 0 divisor. It should be a unit. So you can actually generalize everything, right? So means invertible elements, right? So all those kind of modifications are possible. But anyway, let us take an example here and see what happens. But okay, so maybe I should write down the formula for addition in this case. Actually, if P is a point x1, y1, and Q is a point x2, y2, then we have so in fact there are two cases. If x2 is equal to x1 and y2 is equal to minus y1, then in that case P plus Q is equal to point at infinity. Okay. Otherwise, P plus Q is equal to x3 comma y3, right? Where I can write down what is x3 and what is y3 here. So x3 is lambda square minus x1 minus x2 and y3 is lambda times x1 minus x3 minus y1. What is lambda? So lambda I can compute here. Uh, lambda is, I think you just saw this derivation, y2 minus y1 times x2 minus x1 is inverse if p is not equal to q, or it is 3x1 square plus a 2y1 inverse if p is equal to q. Okay, so this is the addition formula. So actually, so you can verify. So I'm looking at this case only, that now you can verify all the 4 properties of a group. All this collection of points on this elliptic curve forms a group. Means if you take any point P, take another point Q, P plus Q is also a third point in the set. Okay, so there is a closure property. Second is, what is the second property of group? Closure, associative, existence of identity, and existence of inverse, right? So you can see that identity is point at infinity is the identity, because p plus o is equal to o plus p is equal to p for every p in elliptic curve, right? So that is the third property, and so for any point p there is a inverse point q also you can find out, right? On the, so basically this whole thing forms a group. This is a very, very important thing, and actually the structure of this group, depending upon what kind of curve you are taking, is quite varying. And it is very recently people have found the structure of the group for the integer modulo n case. Actually, it's a very, very complicated structure. I mean, so there are different cases depending upon certain conditions. What is the structure of this group? Okay, so yeah, so but for the simple case, this modulo p is a very simple case actually. So you can actually work out many things here. So you need to at least know these rules for addition of 2 points on the elliptic curve. Okay, so now I am ready to take the example for you. Yeah, example, E is y square is equal to x cube plus x plus 6, and we are working over integer modulo 11. So the task is to find out the points x comma y over z1 square such that it will satisfy this equation. So any idea how do we approach this problem? I need to, so I told you about how to add 2 points, right? But the question is, how do you find these points? Any idea? So by looking at this equation, it's very simple. It's actually solving equation is a very, very important task. How do you find? So one way, I mean, there are different algorithms, of course, in the literature, but I'm not, just bare thinking, bare minimum thinking. How do we approach this problem? So we know that since x and y are in Z11, right? I have to find those points x comma y in Z11, so I can vary them and see which one is satisfying the equation, right? That is one way, right? So essentially what I can do, suppose I vary x over z11, right? So we'll get different y square, right? So then y square is equal to that fixed number, whatever we are getting, or x cube plus x plus 6 modulo 11, we will be getting some number. So whether that number is quadratic residue, because y square is equal to that fixed number a or whatever b, right? So what is that number, y, such that, so we need to find a number y such that y square is equal to that fixed number. If we can solve this, that means essentially we are asking whether that number that we compute on the right hand side modulo 11 is a quadratic residue. So problem reduces to finding quadratic residues basically, right? So I can make a table, just vary all x. It's a very simple and intuitive approach. So let me do that. I mean, of course, you can write a computer program to actually do these activities and find a solution. But so here is what our approach. For every x in Z11, check if z is equal to x cube plus x plus 6 mod 11 is quadratic residue. right? Because right hand side quantity is z, y square is equal to z. So I am asking when z is a quadratic residue, right? Because y square, that's the definition of quadratic residue, right? And by Euler's criteria, we know that y is quadratic residue mod p, some number y, then y raised to power p minus 1 by 2 is congruent to 1 mod p. I think you remember this criteria. A number y is a quadratic residue if we have this condition, right? So basically, I can look at when I will be able to solve this. So let me just do these calculations for you. For prime, p congruent to 3 mod 4, I am just computing. Plus minus y raised to power p plus 1 by 4 whole square. Okay, is equal to y raised to power p plus 1 by 2 mod p is equal to y raised to power p minus 1 by 2 into y mod p is equal to y raised to power p minus 1 by 2. Sorry, is equal to y mod p. Right, so that means we have plus minus z raised to power. This is a general thing. So here in our case, 11 plus 1 by 4 mod 11 is equal to plus minus z cube mod 11. So now basically I can check. So what I can check, I'll write x cube plus x plus 6 mod 11, whether it is quadratic residue or not, and what is the value of y. If x is 0, this quantity, right hand side quantity is 6. Quadratic residue, no. X equal to 1, this value is 8. You can compute, right? So if when x is equal to 0, obviously this value is 6 because x cube plus x plus 6, right? We have only this quantity here. So can you complete this table? So we just run x equal to 0, we get 6 here. When x equal to 1, it is 1 plus 6, which is 8, right? Just so I'm just plugging all the values of x modulo 11, right? How many? So how many? So there'll be all these values I can put, and then I can come check whatever. So this is our z we are getting, and I'm asking when it is a quadratic residue and when it will be a quadratic residue. So then in that case there will be values of it. So one by one, the first case it is no, second case it is no. When we put x equal to 2, this value is 5, and answer is yes, it is quadratic residues. And what are the values? 4 and 7. So there are two values of y, 4 and 7. So 4 square will give you, what is 4 square? 16, right? 16 modulo 11 is 5. We are getting this value, right? On the right hand side. Similarly, the other one is 7. Okay. So whenever there is a quadratic residue, we can find the values, right? Go to the next one. 3. This value is 3 here. Is it a quadratic residue? Yes. And those values are 5 and 6. 4, it is 8. Quadratic residues? No. 5, value is 4. Quadratic residue? Yes. 2 and 9. 6, 8. Quadratic residue? No. So I am getting this 2, this 3, this 5, right? Then we can keep on doing. These are the values which we are getting. So we go a bit further. So now we next case is x equal to 7. Okay, so x equal to 7. X, here we have x cube plus x plus 6 modulo 11. and asking a question whether it is quadratic residues or not, and the value of y. So when x is 7, this value is 4, and it is quadratic residues, yes, and the value is 2 comma 9. When it is 8, this is a value we need to consider. When it is 8, this value is 9. It is quadratic residues, yes, the value is 3 comma 8. If this is 9, so this we need to consider. This is 7, quadratic residues, no. Then we have 10. This value is 4, quadratic residues, yes, value is 2 comma 9. So for each x, I am getting two values in certain cases. So total number of points, you can see that 1, 2, 3, 3 here, and 3 here. So 6 cases. In each 6 cases of x, there are two values of y. So how many points? 12 points total. 12 plus 1 point at infinity. So total number of points are 13. So you can easily write a computer program to actually find out these values, right? So E has 13 points. In fact, you will see that it is isomorphic to integer modulo 13 cyclic group. In this special case, so this is a beautiful thing, right? This group, all those 13 points, that group is isomorphic to Z13, right? So it is actually a cyclic group. So let me do some calculations for you. If I take alpha is equal to 2 comma 7 on this elliptic curve, what is 2 alpha? 2 comma 7 plus 2 comma 7. So I can compute the value of lambda from the previous calculations. It will be 3 into 2 square plus 1, 2 into 7 whole inverse mod 11. This value will be 8. You can compute this. So I can compute the value of x3. X3 turns out to be 8 square minus 2 is equal to 5 mod 11, and y3 turns out to be 8 times 2 minus 5 minus 7 mod 11 turns out to be 2. So therefore 2 times 2 comma 7 turns out to be 5 comma 2. So this is our P, this is our M, and this is our Q, right? So I am taking a point P, adding it 2 times, I am getting a point Q. If I take this point and add 3 times, you can add, 4 times you can add, right? We will be getting a point on Q. So basically, similarly, you can check that 3 times alpha, which is 3 times 2 comma 7, turns out to be 8 comma 3. So you can actually use the previous case like the same point, this is 5 comma 2 plus 2 comma 7, and you can compute the value, right? And so on. So I should mention that so I will just write down all the values here. So if alpha is 2 comma 7, you can see that 2 alpha is 5 comma 2, 3 alpha is 8 comma 3, 4 alpha is 10 comma 2. You can compute these values by hand to get a feeling. 5 alpha is 3 comma 6, 6 alpha is 7 comma 9, 7 alpha is 7 comma 2, 8 alpha is equal to 3 comma 5, 9 alpha is equal to 10 comma 9, 10 alpha is equal to 8 comma 8, 11 alpha is equal to 5 comma 9, 12 alpha is equal to 2 comma 4. How many points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're getting all 12 points, right? So alpha is acting as a primitive element. Order of alpha is p minus here actually total size basically, which is 13 minus 1, which is 12, right? So basically here the structure of group is cyclic, I mean cyclic, right? So we are basically with respect to addition, it is forming a cyclic group. So and one point is of course point at infinity, which is there. So this is how you do the thing, right? So in general, so our discrete log problem is if P is a point on this elliptic curve, add m number of times, m times P is equal to Q. P and Q are known to us. Finding m is a difficult task. Okay, and that is how we built a crypto system based on these techniques. Now I think I'll go one step ahead and I will show you. So this was easy case, but just I want to give you a flavor for another case, which is another example. This time I am looking at Galois field with 25 number of elements, which is 5 square. Do you have an idea how do we construct a field with 25 number of elements? So we look for if so we need to first focus on integer modulo 5, which is 0, 1, 2, 3, 4. On this field, I look at a polynomial x square plus 4x plus 2, which is irreducible over z5. So it has no root over z5, right? You can plug in the values of 0, 1, 2, 3, 4 and see there is no root in the ground field. Fine. Okay. Then we construct the field z5x modulo x square plus 4x plus 2. How do we construct this field? Do you have an idea? Or you totally forget? We call it alpha is a root of this equation, right? And attach all those calculations if you remember. So the question is, how do we find our curve is y square is equal to x cube plus x plus 4 over so I can write down this value in 0, 1, alpha, alpha square, and so on, right? That power of alpha we can write down always, where alpha is the root of this equation x square plus 4x plus 2, right? So it's a very good time, 8:38. So now you can do. What a beauty, right? The last year, same time at the same minute also I took the quiz. So you can do the quiz, right? Just solve this and let me. So now you need to recall what is this. First of all, construction of this field will be a difficult task, right? Let me see what you are doing. And then how do we solve this? So basically, again, this quantity will be fixed quantity Z, right? Over field with 25 number of elements. And then I'm checking when that number is a quadratic residue. So I will be doing few calculations for you so that you are not alone, right? So first of all, yeah. So I think obviously it's a two-step problem. First, you compute these values. Can anyone tell me this power of alpha goes up to what? What power of alpha will be 1? So in general, you know, alpha raised to power p raised to power m minus 1 is congruent to 1, right? P raised to power m minus 1 as a bracket, right? Alpha raised to power that quantity is always 1. So here P is 5, m is 2. 5 square minus 1 is what the quantity you can find out, right? So it goes up to that point. I think if you can construct this field, that itself will be an achievement for you because you might have forgot. And this technique you are using since your second year, right? So I hope by now you are very well equipped with this technology, right? So actually, the quiz is good just for brushing up in the morning, like brushing up the teeth, right? Brushing up with something. And so, what about these people who are not here? Like, there are many people who are not here. So that formula of addition of 2 point, but that's a bit far away. First of all, you need to construct this field before you can do anything, right? A field calculation is okay to you, right? So we will be having uh, alpha square is equal to minus 4 alpha minus 2, right? All those calculations. Modulo 5. Modulo 25. I mean, not modulo, yeah, modulo 5. So actually, assuming that you are able to construct, you can keep on doing. I can do some calculations for you. Suppose I want to add 0.23 and alpha plus 1 and 4 alpha. Then I want to first compute lambda. This is our P, this is our Q. Lambda will be 4 alpha minus 3, alpha plus 1 minus 2 inverse. This is 4 alpha plus 2, alpha plus 4 inverse, 4 alpha plus 2, 2 alpha is equal to 3 alpha square plus 4 alpha is equal to 2 alpha plus 4. This is value of lambda. So 2 comma 3 plus alpha plus 1, 4 alpha equal to x3, y3. x3 is equal to 2 alpha plus 4 whole square minus 2 minus alpha minus 1. This simplifies to 4 alpha square plus 3 is equal to 4 alpha. All these places we are taking into account that uh, that alpha is square plus 4 alpha plus 2 is equal to 0. So similarly, we can compute y3 here. 2 alpha plus 4, 2 minus 4 alpha minus 3 is equal to 2 alpha square plus 3 alpha is equal to 1. So 2 comma 3 plus alpha plus 1 comma 4 alpha is equal to 4 alpha comma 1. So this is how you do the addition. तो वो सब एडिशन तो बाद में करेंगे, right? First of all, you should know how to construct the field. I mean, you can easily write down all the powers of alpha up to alpha raised to power p raised to power m minus 1, right? So once you have the powers of alpha and you have the working polynomial that alpha square plus 4 alpha plus 2 is equal to 0, you are all done. I mean, you don't require anything. You can always either make a table to do the calculations, right? And then this quantity I need to vary. So the first, when x is equal to 0, this equation will be y square is equal to 4. So whether 4 is a quadratic residue or not, you need to check that, right? So I can start making the table x, not here, next one, x cube plus x plus 4, checking whether it is quadratic residue and the value of y. When x is 0, this value is 4. Quadratic residues, yes, value is 2 comma 3. When x is 1, this value is 1. Yes, the value is 1 comma 4. This is 2, this value is 4. Yes, the value is 2 comma 3. This is 3, this value is 4. Yes, 2 comma 3. 4, this value is 2. Quadratic residues, yes, the value is 4 alpha plus 3 and alpha plus 2. Now what is the next value in the field? It will be alpha. When x is alpha, this value is 2. Quadratic residues, yes, the value is 4 alpha plus 3 and alpha plus 2. When this is alpha plus 1, this value is 2. Sorry, this value is alpha plus 3. This is quadratic residues, yes, the value is alpha and 4 alpha. And so on. So I am not completing, so I am just leaving, right? So I hope you know the machinery, right? I'm giving you a hint also in the basically quiz, right? So now you can do something, right? So all these values when you, I mean, so for example, when you plug in x is equal to 0, we know that the value is 4. When 4 is quadratic residue, so we need to solve y square is equal to 4. For what value of y in the field, square is will give you 4. So the answer is 2 and 3. 2 square is equal to 4 and 3 square is equal to 4, right? One by one by one by, थोड़ा lengthy है, that's all. इसलिए शायद पूरी क्विज कंप्लीट नहीं कर पाओगे, but at least फील्ड तो बना पाओगे. So we can keep on going. So these are we have done 1, 2, 3, 4, 5, 6, 7 elements. There are 25 elements. Keep on with plugging the values of x, right? Compute this value on the right hand side, which is x cube plus x plus 4. Once you have that value, for each of those values, check whether it is a quadratic residue. Means y square is equal to that z. right? When for that given z, when I can find two values of y, I mean, I want to find a value of y such that y square is equal to that value z, right? And then, so whenever we can, we call it as a quadratic residue, and the values are given here, right? Hmm? देखिए क्या कर रहे हो, कुछ कर पा रहे हो? एग्जाम कंपलसरी कर दें क्या सबके लिए, फाइनल एग्जाम? पॉलिसी तो डायनेमिक होती है ना। ठीक है, आई थिंक व्हाट वी कैन डू, अभी तो टाइम हो गया है, घर से कर लो अपना, और क्या फिर, ठीक है। वैसे फाइनल एग्जाम का मैं सोच रहा हूँ, आई मे बी, आई डोंट नो व्हाट इज योर चॉइस, यू वांट टू गिव? In the project only few people are doing, I don't know what other people are doing, so anyway.